Hey, in this video we're going to go through another example of backtracking in Prolog. It's basically just going to show you another example of how backtracking is used and sort of helps us to get our head around it, because backtracking can be a little bit confusing at times. So yeah, what I've done is I've just created a simple example here which I think illustrates backtracking quite well. And what we'll do is we'll just step through it piece by piece, and then slowly I'll start to explain it through a diagram. So we've just got 4 products here. What we're going to do is ask Prolog to return us back a list containing 4 unique elements, which are going to be 4 unique products. So in our terminal here on the left, it's going to look like this. Our query is unique products. We'll pass it a list, and the list will be populated with a unique list of 4 products. So you might be thinking that this list is in the exact same order as what our facts were defined in the knowledge base as. And you might be thinking, well, it's as easy as just Prolog scanning line by line through the knowledge base and chucking it in the list. So you might be thinking Prolog just chucks hat in the list, then it chucks shoe in the list, phone and then car, and we end up with this result. But Prolog has to work through this systematically, and to arrive at the solution it has to use backtracking, which is basically what this video is all about. So I'll just explain what this code all means, and then we'll get into the diagram. So what it's doing is, first of all, this is the rule. We've got this rule here. This is the rule body. So Prolog will establish or bind 4 product names to these variables here, and we don't know what they are, so they could contain duplicates, we don't know. But then once it has the values for all these products here, then it goes and calls this unique predicate, which tells us, which will return true if the list is all unique. Otherwise it will return false if there's at least 1 duplicate. So this predicate here called unique is basically, it's using the same strategy as one of my previous videos where we looked at how to remove duplicate elements from a list. And just quickly, all it does is it creates a separate list here called scene. It starts off empty, so when the head in the list P1 gets checked, P1 is P1 in the list scene already. If it isn't, then we'll add P1 to the list. And then say P1 and P2 are the same, the next time we check is P2 in the scene list, then if it's the same as P1, then it will be in the scene list. So therefore we'll come down here and we'll fail. Therefore this will return false, and we know that this list isn't unique. So when unique returns false, then we'll end up backtracking back up to the previous level before we return false. So Prolog will end up looking for another product here from the knowledge base, and then go ahead and evaluate, are these 4 variables unique again. So I'm going to start to explain this in a diagram, because it's going to be far easier and it will help visualize how it's actually working. So to kick things off, right, Prolog starts at the top of this rule body, and it basically says to itself, okay, I need to start at the very top of the knowledge base and find something that unifies with this goal here. So our goal is to find something that starts with product. So line 1 is checked, and because these are all variables, P1's a variable, so it can accept any value for the purpose of unifying these two. So P1 ends up being hat, which is basically what I've got here. P2, Prolog again scans the knowledge base starting from the top to find something that matches, and hat's the very first thing, so hat's going to be unified or binded to all of these variables, because for every one of these, Prolog's going to start at the very top of the knowledge base. And I've got these markers here which correspond to the colours of all the different levels. So you can think of this as the highest level, the next highest, the third highest, and the deepest level is 4. And these markers are how Prolog remembers where it's currently at. so it doesn't get lost in its backtracking process. So this semicolon is a logical AND statement in Prolog, so this is one big conjunction. So once values are binded to all these, this whole thing's true. Therefore, our next step is to go and evaluate, is this list containing all hats unique? And of course it's not. So false is returned, so we jump back up a level and we need to find another value for P4. So here's the secret basically. Prolog, we're at P4, the deepest level. Prolog's like, okay, I remember where I am. I'm currently at hat, but I need to find another. I need to go check the knowledge base to see if anything else matches that I can check. So Prolog unbinds hat from P4 and then continues scanning through the knowledge base to find something else that this goal can match to. So this goal can unify to product shoe. So therefore we go ahead and Prolog goes ahead and checks can, you know, if P4 is binded to shoe, does that mean hat and shoe is unique? Because remember, P1, P2 and P3 aren't changed. All we're doing is checking all the options for the deepest level first. So hat and shoe are checked to be unique and they're not, so false is returned. So therefore shoe is unbinded from P4. Prolog is like, okay, let's keep checking the knowledge base to see if anything else matches. I run into phone. Phone is next. And Prolog goes through the same process. Now this is phone. So hat, and phone. These aren't unique, so false is returned. So again, Prolog's like, is there anything else in the knowledge base that I need to check for P4? And there's one last thing, is car. And you know, it's going to be the same story again. Is hat and car unique? False. So Prolog's like, okay, is there anything else in the knowledge base that I need to check for P4? No, there isn't. So the only thing that it can do now is it has to backtrack back up a level, P to P3. So Prolog's like, okay, I'm back to P3 now. I need to resume from where I last left off. I last left off at hat because I know where I was, because I keep these markers here, and Prolog would internally keep these markers to keep track of where it is. So now Prolog's like, okay, I'll unbind hat from P3 and check the knowledge base for something else that I can bind to that unifies with this goal. So product shoe binds here. So now we check shoe, and if you guess what we do next, because we've got product P1 and P2 change the same, because we haven't backtracked back up that far yet. We're only backtracked back to the next level above 4, which is 3. So now Prolog needs to check all the values for 4 again, based on this new value for the level above for product 3. So to do this, Prolog has to start at the very top of the knowledge base to try and find something that binds to P4. So product P4, we start at the very top of the knowledge base, and product hat unifies with P4. So hat gets binded to P4. So hat, going to put this down a bit to make them line up. So we check hat is, so product P1, P2 are both hat, P3 is shoe, and P4 is hat. And there's multiple hats here, so they're not unique. So therefore Prolog checks to see if there's anything else that matches for P4. It next encounters shoe. So P4 is now shoe, hat, shoe, and shoe. These are not unique, so it returns false. Prolog keeps looking for other entries for P4. Next encounters phone, hat, shoe, phone. unique returns false. Prolog keeps looking for P4. It has to exhaust all the options for P4 again before it goes back to P3. So that's the key to remember here, is exhaust all the options for whatever level you're on at the deepest level first before you go back. So product car, hat, shoe, car isn't unique because these two are still duplicates. Is there anything else for P4 that Prolog can match to? No. Therefore Prolog has to go back, backtrack back up, so P3 was on shoe. Shoe's unbinded from P3. Prolog knows where it was last at because we've kept this marker here. Prolog continues to scan the knowledge base for something else that can match for P3, and it runs into phone. So we can establish a new level here, say phone. So now Prolog needs to, it's got a new value for P3, now it needs to check all the values for P4 at the deepest level first. So it has to start from the top of the knowledge base at hat again. And essentially you're going to run into this situation where nothing that happens from this point on will be unique because product 1 and product 2 are still hat, but Prolog still has to go through this whole process to get back up to these levels. So this is basically just going through the motions, this part, but obviously Prolog doesn't know this because it just has to do this to get back up here. So for the purpose of shortening this video, we can assume that all entries for P4 are checked. So hat, shoe, phone and car, these are all checked here because they're all checked, but the unique predicate will always return false because hat, phone and whatever else down here isn't going to make a difference. So this will return all false, and Prolog will end up kicking back up a level, so backtracking back up to P3. So Prolog remembers where it was last at for product 3, so now it goes through the knowledge base and checks what else it can match to. So car, and again we can sort of shortcut this because we know that these two are still hats, so it's not going to be unique. But again, Prolog will have to check every entry for P4 again because just going through the motions. So all of these are checked for P4. Unique here always returns false because there's two hats here. So then we backtrack back up again. And Prolog's like, okay, is there anything else for P3 that I can check out to see if it matches? No. So that means we have to go back up a level to the second highest level. So Prolog knows where it was at product 2 because we've got this blue marker here that indicates we're at product hat. So hat is unbinded from P2, so this means P2 can try and be rebinded to any other values that match. So the next goal or fact, the next fact that unifies with this goal here is product shoe. So now we can try product shoe for the second level, and we don't go back to the highest level product. We're still on level 2 here, but we've given it another value, so this means we have to go and check the next deepest level 3 and 4 for all possible values based on, and check if all the values, if any value at product 3 or product 4 is gonna make hat, shoe, something here unique. So we have to go to product 3 here and find something that, we have to scan the knowledge base from the top again and find something that matches. So we run into hat, and we've got a value for 1, 2 and 3. Now we need to get a value for 4, so Prolog starts the search from the top of the knowledge base again. So it runs into hat, and so we've got product 1 is hat, product 2 is shoe, product 3 is hat, and product 4 is hat. There's 3 hats, so it can't be unique. So Prolog will check another value for P4, because we have to exhaust all the options for the deepest level first before we go back. So our deepest level is 4. We have to exhaust all options for 4, but because we've got a hat and a hat here, no matter what we do for P4, it's never going to be unique. So we can just assume that every value for P4 is checked and unique returns false. So Prolog goes back and it unbinds hat from P3 and continues in the knowledge base until it finds another match that it can check out. So we can check out shoe. And running out of a bit of room here, so we'll be finished shortly. There's only a couple more to go. So next we have shoe here. We have to again exhaust all the values for the deepest level again. So to do that, Prolog starts at the top. But these two are shoe, so no matter what we do here, unique's always going to return false because there's 2 shoes. So we can just assume that Prolog exhausts all the options for P4 and runs out of entries to scan. So everything in P4 is checked and unsuccessful. So therefore we backtrack back up to level 3. So product 3 here, since Prolog knows where it was last at, shoes unbinded from P3 variable, and now we keep scanning the knowledge base. So next we check phone. And now we have to find check all the values for the deepest level again. So we start at the very top of the knowledge base. So we check hat first. So is hat, shoe, phone, hat unique? No, because there's 2 hats here. So next Prolog checks another value for P4. Is hat, shoe, phone, shoe unique? No, because we've got 2 shoes. Okay. Prolog checks another value for P4. It runs into phone. Is phone unique? Or is using P4 for the phone for P4 going to make it unique? We've got hat, shoe, phone and phone. There's 2 phones, so it can't be unique. Prolog keeps going through the knowledge base for P4 to find other entries to try and check. Run into car. Is hat, shoe, phone and car unique? Yes, because there's no duplicate elements. So we've got hat here, shoe here, phone here, and car. And this is the very last value that is fed into the unique predicate. Therefore, this will return true. Therefore, this whole rule body is true. Therefore, these values here, binded to these variables, ends up being what's used for the elements that will be contained in this list, which is why we see that P1 contains hat, P2 shoe, and so forth. So that's pretty much the general idea. I guess the main ideas to keep in mind is that the deepest levels are explored fully first, and once these deepest levels are exhausted, we keep back to the last level, and then once all the values are exhausted in this last level, we go back to this last level. But Prolog knows where it was at during the last level, because it keeps these markers, these placeholder markers here, to keep track of where it was at, so it can just resume from the last place it left off. I guess the only difficult thing here is that when the problem that you're trying to solve is complex, it's very hard for you inside your mind to remember where you're last up to. So I guess the main idea is just the concept that we're trying to understand here, not really following the intricate details of how Prolog does it in a complex example, because yeah, it can get really, really complex. But there's one last thing that you might find useful. I have this debug statement here. Basically all it's going to do is just print out what we just went through in my diagram. So I'll just quickly go through this and then wrap the video up. It basically just highlights the fact that the very first thing that we did, everything was hat, but because unique returned false, that means we have to explore every option in the deepest level. So we start off with hat in product 4, but every option in the knowledge base has to be explored for product 4. So hat, shoe, phone and car. Okay, we've done every possible option for product 4, so that means we have to kick back up to level 3 or product 3. And product 3 was originally at hat, but because it had a marker here to remember where it was at, it next goes to shoe. So product 3 is at shoe, and product 4 has to start at the very top again at hat. So then it goes, we have shoe, now we have to exhaust every possible option for product 4 while product 3 remains the same. So product 3 remains shoe, and then product 4 will be hat, shoe, phone and car, all at the same time while shoe is product 3. And because none of these are unique, that means that we backtrack back up to product 3 and go to its next option of phone, and likewise we exhaust all possible options for product 4, so hat, shoe, phone and car. None of these match, so then we go and exhaust the last option for product 3, and because the first two products are always hat, whatever we do for product 3 and 4 is never going to be unique, but we just have to go through the motions to do it, to get back up to the top of levels to change it. So yeah, it's pretty much just following this through to completion, and that's how Prolog ends up in finally calculating its result. But yeah, thanks for listening and hope you enjoyed the video.